Welcome, everybody, to class. We're going to go over Chapter 4 today. Chapter 4, we're going to look at gains to trade and interdependence. I want you to think about these things that are also listed in your chapter outline. Right? Why do nations and people, individuals, choose to be economically interdependent? That is, why are they working together? Why are people trading? Why aren't people just kind of solitary islands producing their own goods and consuming their own goods? Why do they decide to trade with other people? Okay? How can trade make everyone better off? And then finally, we're going to talk about absolute and comparative advantage. And that's all we're going to do in this chapter. So it shouldn't be too long. It's a pretty easy chapter, I think. So, I mean, think of your life, right? You, hair gel from Ohio. Every day, you use things from places all over the world, right? If we just relied on utilizing the resources that we could produce for our own selves, we'd all be like, have really bad-looking hair because we gave ourselves our own haircuts, and our clothes would look terrible because we would make our own clothes, and we'd probably be pretty hungry because we're trying to grow our own food, right? So this concept of separation, specialization, then trade is really integral to what we do every day in our life. It's particularly interesting in this course because I think a lot of times we might maybe see in opinion pieces in magazines or maybe on the internet, people claiming like, oh, you know, you need to separate trade, or like you can't let a country that can produce products at a very, very cheap price trade. It's just not competitive. We need to protect our manufacturers in America, that sort of thing. I want to maybe offer an alternative. I'm not saying that these ideas are necessarily wrong or right, but I just want you to think of this kind of alternative. All right, so the idea of interdependence. One of the 10 principles from Chapter 1 is trade can make everybody better off. And now we're going to learn why people are better off and how this is. Okay? So here's an example. We've got two countries, the United States and Japan. We've got two goods, computers and wheat. And we've got one resource, one input. We've got labor measured in hours. All right, so we're going to look at how much of both of the goods each country produces and then they consume. So let's go ahead and do that. Oh, in two different categories. If a country chooses to be self-sufficient, and then if it trades with the other country. You should learn this word. It's called autarky. We use it, autarky, I think it's spelled like that. We use it in economics to describe the island model of a nation. Autarky meaning you don't trade, okay? The no trade solution, okay? So if a country doesn't trade with other countries, then it can only consume exactly what it produces. Does that make sense? If it trades, it can produce, I don't know, computers, and then it can trade it with another country for wheat. Right? That's the opposite of autarky, and that's called an interdependent solution or a trade solution. Okay? So we're going to look at the solution on the autarkic conditions as well as if it trades with another country. Okay, so first we need to mark the production possibilities in the United States. What do I mean by production possibilities? What are all the possibilities that United States can produce? Okay? And we're going to go ahead and kind of do just a little math. It's not too hard, right? There's 50,000 man-hours of labor available each month for production. Every computer takes 100 hours of labor. Every ton of wheat requires 10 hours of labor. Okay? Clearly, the computer is a slightly different product than the wheat. It's slightly more labor-intensive. That's why it takes 10 times the number of hours. Okay? And so this could be one guy working for 100 hours. It could be 10 guys working for 10 hours. It doesn't matter exactly how we dice it up, but it needs 100 of those 50,000 hours to produce it. Okay. So now we're going to graph the output possibilities. We're going to call it a PPF, which stands for Production Possibilities Frontier. All right. So production possibilities, it's easy to understand, and then a frontier, like a border. So we're going to go ahead and put this on a graph and look at what's the border or the frontier or the maximum amount that this country can produce given the conditions I told you about on that previous slide. So if you just think for a couple of seconds, you can probably do this in your head real quick. We have 50,000 labor hours, right? There is 100 hours for a computer. There's 100 hours per computer. So if I just made just computers, how many computers could I make? 500, right? Good. Excellent. 500. And so we're going to put a little dot there at 500 on the XY axis. So just to remember, a review on how graphing works, right? A dot in the two-dimensional plane gives you two pieces of information. This dot tells you it's at 500 computers, but it simultaneously tells you it's at 0 tons of wheat. Okay? So any dot has two pieces of information. It has the x-coordinate and the y-coordinate. And it's very important in this class that you are aware of both the x and the y coordinates, the pieces of information that this is giving you. Okay? So we're going to draw the dot there because that tells us it's making 500 computers and 0 tons of wheat. And similarly, if we just specialize in wheat, remember wheat is only 10 hours per ton, so 50,000 hours and 10 tons. Now, are those the only 2 points that they can produce at? No, right? They can use maybe half of their people to do computers and half of them to do wheat, or 20% to do computers, or 20% and 80% to do wheat, or something like that, right? Essentially what we have is we have any combination along this line is possible, right? Any combination along this line is possible. That's why we call this the production possibilities frontier, right? Or the border. This is possible. What about this? Is this point right here possible? Absolutely not, right? This is unachievable, okay? This point right here, is this possible? Yeah, it's definitely attainable. But if I'm producing at this point, what do I know about the country? Can I make more? Can I do better? I can definitely do better if I produce here, right? Because I'm not using up all of my labor hours, right? If I produce here, I'm making, let's say, 100 computers and 1,000 hours, or excuse me, 1,000 tons of wheat. I'm only using 100 times 100 is 10,000 plus 10,000 is like 20,000 hours or something like that, right? And I have 50,000 total labor hours. So I have a lot of unemployment probably in my country, right? Because I just don't have that many people working. Okay. So important things to note about the production possibilities frontier. Everything in this triangle is attainable, but this point, even though it's attainable, it's probably pretty stupid. It's not a very good point because I'm not utilizing everything the maximum ability that I can, right? Points out here are unachievable or unattainable. So I can't eat there. I can't consume there at this point. Even though people might want to consume out here, right? We can use more computers and eat more wheat. We'd probably be happier if we could be out here, right? But we can't because we're outside the production possibilities frontier. So this line is kind of like the best of both worlds, right? It's the most I can make. I'm utilizing all my resources. I don't have any employment if I'm at this line, right? And I can choose anywhere along this line the amount of computers or the amount of wheat based upon the preferences in my society, right? We're not actually going to talk about in this class how we decide which point along here to produce at. We're not, because that has to do with micro theory, the theory of the way people think, okay? But just realize that we can produce anywhere along this line according to the preferences of society. Yes, sir?
Why is it 5,000 tons, not 500?
Why is it 5,000 tons, not 500 tons? Because there's 50,000 hours, and it was 10 tons per 50,000 total hours, and there was 10 hours per ton. Let me go back and show you. Right? 1 ton requires 10 hours. So we had 50,000 divided by 10 is equal to 5,000. Okay, good question. Way to pay attention. See what's going on. Okay. Any other questions? Awesome. Let's continue. So without trade, it's very simple. whatever point that the United States decides to produce at, right? If they decide to produce at 401,000, I don't know if that's a point maybe, 401,000, guess how many computers and tons of wheat the United States is going to consume? 401,000. It's no secret, right? It's a closed country, no trade. We're going to think about the autarkic or the autarky solution. So whatever point along there we pick, the United States is going to eat or consume at. Let's go ahead and pick half and half. Okay? So let's do half and half, and we're at 250 and 2,500 tons of wheat. Let's just imagine that. I mean, that seems reasonable that the country both wants to, play World of Warcraft on their computers and eat some bread at the same time with the wheat, right? So we probably need both. They're probably not going to, you probably won't find the country producing all the way down here at 500 computers, because then what would they eat, right? You probably won't see them producing all the way at 5,000 tons of wheat, because then how would they play World of Warcraft? I don't know if they don't have computers, right? So I think it's a reasonable assumption to suppose they produce 2,500 tons of wheat and 250 computers. In this case, in the autarky solution, they're also consuming 250 computers and 2,500 tons of wheat, right? Make sense? It's kind of self-explanatory, but I just want to make sure that we're on the same page here. All right, so here's what I want you to do. I want you to do this same thing for Japan, all right, except for the numbers are going to change. You can do this. I've provided on your handout a place for you to draw this PPF, okay? And here's the important data. If you have a computer, a calculator, or a computer, something with a calculator on it, feel free to use it on your phone. If you'd like to use your calculator on your phone, feel free to use it. But what I want you to do is the exact same thing that we did. I want computers on this axis. I want wheat on this axis. And I want you to draw the PPF, the Production Possibilities Frontier. Okay, so that we can help each other out. Where's the x-intercept of this PPF? 240. Thank you. Where is the y-intercept of this guy? 1,200. Okay, and then what's the last step we do? Connect the two. Okay, excellent, excellent. Let's go ahead and throw it down there. Okay, we had 240, 1,200, any combination along there. Okay? Very good. So let's ask the same question. What happened if Japan doesn't end up trading? Well, whatever they produce, Japan will also consume because it's not trading. So let's make the same assumption that they do half and half again. It's going to produce and consume right there. 120 computers and 600 tons of wheat. So we'll do produce and consume. Make that a little bigger so you can see that. It's going to produce and consume under autarky. Right at that point. Okay? Pretty self-explanatory. But let's add something else, the little twist into this chapter, which is what? Trade, right? Let's see if they can do better if they trade, all right? And by better, it makes sense. I'm talking about any location out here, right? Because this is the best that they can do all by themselves, but it just makes sense. It makes sense if I'm at this point, which is 120 and 600, if I all of a sudden could just give this person 10 more computers, this country, they'd be better off, right? So I'm going to define, for purposes of this analysis, everything outside of here as better, okay? Because I can eat more, I can consume more, right? So let's see if they're going to be better under a trading solution. So just to review, without the trade, the U.S. got 250 computers and 2,500 tons of wheat. And the Japanese people, we're here at 120 and 600. 120 and 600. right? That's the autarky solution. And now let's go ahead and compare these solutions to the trading solution, right? Well, before we need to do that, we're like, well, how much are they going to trade, right? And this, of course, depends on the preferences of the individuals in the country. However, we'll just make up some for purposes of the example here, okay? Let's say that the US produces 3,400 tons of wheat, okay? So let me draw, perhaps, the US PPF on this as well. Remind me, what did this go to, 5,000 or something? So US was at 5,000, and then they went to how many computers? 500. So United States was here. Okay. And under their autarky solution, they were eating at, I think, 2,500 and 250, right? The problem is I've got to make this a little bit better. Okay, sorry, it's a little ugly. Okay, so that was the autarky solution for the United States. Now let's suppose, however, that they produce 3,400 tons of wheat. Okay? So we're not at this solution anymore. We're going to produce 3,400 tons of wheat. So we're like maybe here somewhere. Yeah? How many computers is the United States able to produce with 3,400 tons of wheat? Here somewhere. 3,400. How would we figure that out? We could do two ways. One, we can connect it down. Unfortunately, this graph is not on graph paper, so it might not turn out well. But we could do it mathematically, right? Figure out how many labor hours that are required. So if I make 3,400 tons of wheat, how many labor hours does that take? 1 ton is 10 labor hours, remember from earlier. So this would be 34,000 tons, or 34,000 labor hours. So there's 50,000 minus 34,000 equals 16,000. And how many computers does that equal to? 160 computers. Awesome. So this should come down here to 160. So the United States is producing at this point. Now, if they were going to not trade, they would just also be eating at this point too. Okay? Let's suppose Japan also now produces 240 computers. So where's Japan on in its trading point? Where is Japan? This is production with trade. They're here, right? Does that make sense to everybody? They're there at 240 computers. Are they making any wheat? No. Are their citizens going to starve, though? Yes, under autarky, right? So what are we going to do next is our next move here. Trade, right? So just imagine in your brain, what is Japan going to receive as an import? Wheat. And how are they going to pay for it? With computers, right? So let's there's the point that we drew, the 3,400 and 160. Very good. Here's Japan's. They're all the way down here at this point, right here. And they're going to export and import. Let's go ahead and define those terms, though, so you understand what they are. Exports is anything that you produce it here in your country and then you sell it abroad. Okay? The imports, and to export means to send that domestically produced good abroad. Abroad means a different country. Import, so goods produced in another country and you bring them here. Okay? That's what it means in this class. To import something means to purchase goods in another country and bring them here. And let's talk about the exports and imports. Let's suppose the United States is exporting 700 tons of wheat to Japan, and then it imports 110 computers. How did I get to these numbers? Just made them up. All right. In real life, this is determined by how hungry the people in Japan are, how many computers they're willing to give up. That's what this is actually determined by, right? For purposes of this example, though, I wanted to show you guys something where the countries are clearly better off. So I'm like, hey, if they just pick this, both countries will end up being better off, and I'll show you how. So let's look at this. So Japan imports 700 tons of wheat and exports 110 computers, right? Because Japan does the opposite of what the United States did, right? How much of each good is consumed in the U.S.? And plot this combination on the U.S. PPF, right? We will, let's actually think about that. How much of each good is consumed in the United States? So they make 3,400 tons of wheat, but they're exporting how many tons of wheat? 700. So they're only, how much is left in the United States for eating? 2,700. Very good. Very good. And then, how many computers are available for using in America? They made 160, but then what they'd end up doing? They got 110 more, right, for the wheat that they sent away. So what is that? 160 plus 110 is 270. So what were the numbers again? 2,700 and 270? Was that what they were? 2,700 and 270. Consumption with trade. What do we note about this point? What is the very awesome thing about this point? Is it located in the part of the graph that I declared was, that I assigned was better than before? Yeah, it absolutely is, right? Anything that's outside of this projection possibilities frontier is better. So the United States, at least so far in this analysis, turns out to be better if they specialize a little bit more in wheat, and Japan specializes a little more in computers. Okay? Now let's do this for Japan. Okay, Japan's a little bit easier. They make 240 computers, and how much are they sending away? 110. So how many of them are left? 130 computers. So we're over here somewhere. And how much are they eating? Did they make any wheat for their own self? No. But where are they getting their wheat from? United States. And how much is that? 700. So we're up here, I guess here. We're consumption with trade. It just so happens that Japan is also better off with trade. This is a kind of, if this is the first time you've ever seen this, this should be a little bit of a striking result, right? That the countries somehow are both better off by trading. You might be thinking, like, how is this happening? When they were producing under these autarky conditions, there wasn't people like sitting around being lazy in the countries. It seems like all of a sudden people are eating more out of thin air, right? You just got to be thinking about it. Let's go over the graphs and a little table with the numbers again. So United States produced 160 computers and did 3,400 tons of wheat. They imported 110 computers. They exported 700 tons of wheat, and so that leaves them with 270 and 2,700. Okay? So this point corresponds exactly to that point right there. So they're definitely better off. Because remember, we'll compare with their old solution before. But clearly you can tell it's in the better zone. Let's do the same thing for Japan. They made 240 computers and no wheat. They imported 700 tons of wheat. They exported 110 computers. Therefore, how much are they eating? They're eating at this point, right here. 160 or 130 and 700. 130 and 700. Really interesting. Very interesting, really. Okay, so let's compare the United States before and after, right? Computers, they had 250 computers before. That's this point. After, they had 270 computers. So my graph's a little messed up. It should be over here, right? But they gained 20 extra computers than they had before. Okay. They were eating 2,500 tons of wheat before. After trade, they were making 2,700 tons of wheat. So there is 200 extra tons available for consumption in the United States, right? So if you didn't believe it from the graph, believe it from here, it's very clear that they're able to consume more with trade than under the autarky, without trade solution. Pretty interesting. Pretty cool. Let's say the same thing for Japan, right? They were able to consume 120 without trade, but 130 computers with trade. They get to use 10 more computers. And the same thing for wheat. They get 100 more tons of wheat. All right? Awesome. Okay, so the question is, where did these things come from? Did they come from thin air? You know, if you don't think, if you just think about it mathematically, it seems like we must have done something wrong, because they were all, when they were at their autarky solutions, they were producing as much as they could. I mean, it's not like people were sitting around. So where did these extra things come from? Okay. Turns out that there's this thing called absolute advantage. And it's the ability to produce a good using fewer inputs than another producer. Okay? So the United States has an absolute advantage in wheat. Right? A ton of wheat uses 10 hours of labor versus 25 hours of labor in Japan. Okay? So this might not be the answer to where these gains came from, but I just want you to start thinking about how the countries are different. Okay? This might not be the total answer to where did the extra computers and wheat come from. But I want you to think about this. So really, it's more efficient to produce, it's perhaps more efficient to produce wheat in what country? Perhaps, if you just look at this, right? Like, it might be better to produce in the United States, right? So United States is better, has an absolute advantage in producing wheat. Okay? Maybe that we have more tractors, or maybe we have more arable land, or for whatever reason it's easier to produce wheat in the United States. Note that this does not mean that United States has more workers or more citizens. That's not what absolute advantage means. It just means how many hours does it take to make 1 ton of wheat. It's fewer in the United States. This probably has something to do with technology or technological progress, right? In our world in 2014, if I look at differences in the number of hours it takes to make something, it probably has something to do with technology. Okay, maybe we use better tractors or better fertilizers or something. I don't know. Okay, so here's a thought, and this is kind of like a no-doubt thing. If one country has an absolute advantage in one good and another country has an absolute advantage in another good, what should they probably just do? Yes, they should just produce the things that they have absolute advantages for and then trade with each other. Okay? Is that the case in this situation, though? Right? The answer to that is no. Check this out. Who has the absolute advantage in computers? Well, let's look at it. Producing a computer requires 125 labor hours in Japan, but only 100 labor hours in the United States. So who has the absolute advantage in producing computers? Japan. Careful. It takes, for just one computer, it takes 125 hours in Japan. But it only takes 100 in the United States. So actually, who has the absolute advantage? Exactly. The United States has the absolute advantage. This idea that I told you a second ago, if the two countries have two absolute advantages, they should just specialize in that. That was true. But it won't work in this situation. Because who has the absolute advantage in both goods? United States. Okay? Again, it doesn't mean that the United States has more population or has a bigger number of labor hours to pull from. It just means that like the production process maybe is a little more technologically advanced, and we can make a computer quicker, right? And it's cheaper in the terms of if I have to pay people for their labor, right? So it's cheaper from one way to think about it. It uses less labor as the input, okay? So although what I told you about the absolute advantage is true, if two countries have absolute advantages, they should just stick to what their absolute advantage is. That's not the case here. So there must be some other reason why we're getting this really cool result, where people are able to eat more, where we're just all of a sudden producing more out of thin air, okay? And the answer to that is going to be on the next slide. But here's the question, right? If the United States has the absolute advantage in both, some people might just say, just have the United States make both, right? I mean, that might be the thought. Why have another country which it's actually less efficient and it wastes a little more labor hours and costs a little more? Why have them produce something? Okay. And the other thing to note is that even though Japan does not have an absolute advantage in anything, Japan doesn't have an absolute advantage in anything in this problem, both countries are better off, right? So there's another way to think about the costs. And the key is when two countries specialize in the thing that they have the cheapest cost for, then that's when the country's better off. And the two ways to think about costs are, one, this computer costs 100 labor hours, right? It took me 100 hours of labor to build this computer. That's one way to think of cost. That's the absolute advantage idea of cost. There's this other idea of cost. Those of you who've taken micro, you'll know that there's another type of cost called opportunity cost, okay? And in this world, we ask, well, if I build one computer, it's using 100 labor hours, but how much wheat could I have grown in that same 100 labor hours, right? In the United States, it turns out to be 10 tons of wheat, right? So over in this world, in the input price world, we're talking about it costs 100 hours to make a computer. Over in the opportunity cost world, we're talking it costs 10 tons of wheat to make a computer. So there's two ways to think about this cost, okay? And the absolute advantage, like I said, is the cost of the good in terms of the inputs required to produce it, how much labor is required. And then there's this other opportunity, is the opportunity cost. And it just turns out that opportunity cost is always the relevant cost for decision making when you're in economics, right? Those of you guys who've taken micro realize that you're almost always thinking in terms of opportunity cost. Okay? So the opportunity cost of the computer in this example is just how much wheat did I have to give up, right? Because if you look along anybody's PPF, right, as I make more computers, as I go this way, I'm necessarily going down in the wheat, right? So how much am I giving up in terms of wheat? Also, it tells you something. The slope of these lines tells you something about the opportunity cost, right? How much it's giving up. Okay. So let's talk about this. When somebody has a cheaper opportunity cost, it's called comparative advantage. When someone has a cheaper opportunity cost, it's called comparative advantage. When someone has a cheaper, the input cost is called absolute advantage, right? But comparative advantage is a cheaper opportunity cost. So let's look. What country has the comparative advantage in computers? Okay? What country has the comparative advantage in computers? Another way to say that is which country's PPF is flatter. Which country's PPF is flatter, right? I'll give you a second to write that down because I want to tell you a handy thing. The slope of the PPF tells you the opportunity cost of the thing on the x-axis. The slope of the PPF tells you the opportunity cost of the thing on the x-axis. Okay? So if I have a really steep PPF, right? It's a large number. The opportunity cost of computers is high. If I have a really flat PPF, the opportunity cost of computers is low. Okay? So let's look at it. The opportunity cost of a computer in the United States is how much? Well, a computer is 100 hours. 100 hours you could use to make 10 tons of wheat, right? Computer equals, therefore, 10 tons of wheat. So let's write that down. In the US, computer costs 10 tons of wheat. Okay, in Japan, on the other hand, it only costs 5 tons of wheat. Now why? Didn't we just say it took more labor hours in Japan to make a computer? Well, yes, it does. But if we look in that in terms of how much wheat that Japan could have produced in the same time it made a computer, it's actually less. So if you think about Japan, it takes 125 hours to make a computer. But with that 125 hours, I could have made only 5 tons of wheat. Because remember, it takes 25 hours to make a ton of wheat in Japan. Right? So 125 divided by 25 is 5 tons of wheat. So in Japan, a computer costs 5 wheat. Right? In this economy, where there's only 2 goods and 2 countries, we don't yet have money or anything like that, right? We directly talk about the price of one good in terms of the amount of the other good that's needed to purchase that. Okay? There's no money. It's just a simple 2-good economy. A computer costs 10 wheat here. A computer costs 5 wheat here. Which country is it cheaper in terms of opportunity cost? Japan, right? So this is really, really interesting. Because if we think in terms of the labor required to make a computer, i.e. absolute advantage, it's cheaper in the United States. If we think in terms of the amount of wheat that we have to give up to get the computer, i.e. comparative advantage, it's cheaper in Japan. Okay? So, like I said before, opportunity cost is oftentimes the relevant cost to analyze when it comes to economic thinking. Okay? What country should should specialize in computers? What country? Japan. Very good. Because it's cheaper there in terms of opportunity costs. Okay? So this is interesting, and it kind of breathes to me a sigh of relief for trading amongst countries, right? United States had an absolute advantage, i.e. was better at every single product, right? Even though the United States was better at every single product, it's still, quote, cheaper to make computers in Japan. Every country can benefit from a comparative advantage, okay? And this is cool. The way that we've assigned a comparative advantage, every country always has a comparative advantage. Even if they never have an absolute advantage in anything, they always have a comparative advantage in something that gives them the opportunity to produce, okay? So these gains come from the fact that we switched from the autarky solution where Japan was not specializing in computers to specializing in the thing where it's cheapest for it to do, and that's why the gains happened. Meaning that's why both are better off. Okay. So when each country specializes in the good for which it has the comparative advantage, right, there's less waste overall, and so the total production in the whole world is bigger. We call that the size of the, quote, pie. Right? We're making the whole pie bigger. Everybody takes their slice. Right? So there's 2 ways, if you think about it, of getting more production for a country. Right? You can either try to make your slice of the pie bigger, or you could stay with the same slice, same size slice, but make the whole pie bigger. Does that make sense? A lot of what we're going to do in this class comes from the philosophy it's better just to make the whole pie bigger. Even if your slice is pathetic, man. If we just make the whole pie bigger, you'll at least be eating more, right? The reason why we do that is because it's a lot easier to convince these people with really big old fat shares of the pie, these large rich countries, to go for that than to go for making their slice of the pie smaller, right? And I mean, it makes sense too, right? If we can make the whole pie bigger, everyone necessarily is better off. No one is worse off. So it's kind of an attractive solution, really. And of course, it applies to individuals too, right? A farmer and a rancher. Farmer is going to specialize in producing wheat and corn, and the rancher is going to specialize in producing cows, right? When they specialize, they have lower opportunity costs, right? Because if I try to have cows and corn, and the cows are walking on my corn plants, and it's just ugly, right? So we specialize, and then we trade with each other, and individuals, countries, companies are all better off. Okay? So let's do this real quick so you guys can think about absolute and comparative advantage. So we have two countries, Argentina and Brazil, 10,000 hours of labor. Okay? So they're similar sized countries, same size labor force. Argentina, a pound of coffee is 2 hours of labor, and a bottle of wine requires 4 hours of labor. In Brazil, a pound of coffee requires 1 hour, and a bottle of wine requires 5 hours. So answer these questions. Who has the absolute advantage in coffee, and who has the comparative advantage in wine? All right, I'm going to erase this, and I'll give you guys a chance to think about that. Let's start with this absolute advantage question. So we could draw a graph, which I won't do. Feel free to do it. We can think of it numerically, though, too. Which country is it cheaper in terms of the inputs? Right? For which country is it cheaper in terms of inputs? That's absolute advantage for coffee. Brazil. Brazil is correct. Why? Exactly. It only costs 1 hour to produce coffee here. It costs 2 hours in terms of input hours to produce coffee in Argentina. So Brazil clearly has the absolute advantage in coffee. Excellent. Now, the comparative advantage, which can sometimes be a little bit more tricky, okay? And there are questions in the homework that make sure you understand how to calculate this comparative advantage thing. Who has a comparative advantage in the production of wine? Before we do that, let's go through and just calculate the opportunity cost of wine in Argentina. What's the opportunity cost of wine here? Well, let's think. To make 1 bottle of wine, it takes how many hours? 4. In those 4 hours, how much coffee could I have made? 2. So the opportunity cost of wine is 2 coffee here. All right? Let's do the opportunity cost of wine here. To make 1 wine in Brazil, it takes how many hours?
5.
In those 5 hours, how much coffee could I have made? 5. Very good. Exactly. Okay. Okay. So in terms of opportunity cost, i.e., how much coffee am I giving up every time I make wine, where is wine cheaper? Argentina, right? It's the lowest price. Because in the simple two-good economy, I don't have money yet. I just pay for everything in the other good. So wine's costing me 2 here. It's costing me 5 here. Like any bargain shopper, we should always shop at the cheapest place, right? If it's the exact same good. All right? So these people have the comparative advantage in wine. Which, by the way, because of the way math works, means that these people have the comparative advantage in coffee. Okay? One person always has a comparative advantage, right? It can't be true that one person has both the comparative advantage in both of them. One of the people can have an absolute advantage in both of them. This is not the case here. But remember the Japan and United States example we did a little earlier? We had the United States having absolute advantage in everything. Okay? That can happen. It can't happen that someone has a comparative advantage in everything. Right? The comparative advantage always mathematically has to work out so that one person has each. Okay? All right, so there's the Brazil having an absolute advantage in coffee. We've got that. Okay. Argentina has a comparative advantage in wine. Right? We have 2 pounds of coffee here versus 5 pounds. Okay. Excellent. Excellent, excellent. So, unanswered questions. I pointed this out a little earlier. When I was talking about the trading solution and all of the trading solutions that we've done, I just kind of gave you, oh, let's just suppose that United States made 3,600 tons of wheat or blank, something like that, right? Where are these coming from? I didn't teach you guys that, and that's not beyond the scope of this class, actually. I won't teach you how they decide exactly the number, okay? So that's this right here. How much do they produce? How much do they trade? How much do they sell it for? How much, what's the world price? Okay, we didn't go over that because they're determined by the preferences of consumers, and that's kind of more of the scope of a different class. Okay, and we're actually not going to study the next chapter in this class, so don't worry about it. But the thing that's important is this right here: trade can make everyone better off. It can, right? I didn't prove to you today that it does, right? I think that we can probably all look out in the world and see how trade has gone wrong and has made people worse off, right? But all that I was trying to show to you today was the existence of some sort of trading scheme where everybody's better off, okay? That's all that I tried to show you today. All right. And that is the end of chapter 3.